Hello everyone, we are back. So today I brought a very special topic for you, incident which has helped us to think bigger. Have you ever came across a situation where frozen transmitter value that doesn't change could actually lead to a major incident? Well, I have, and it taught me one of the most powerful lesson of my career. A few years ago, when I was in the operation maintenance, we had an incident where one of our vacuum column collapsed. Yes, the entire column gave way because of negative pressure, and it was 40 feet tall column. The column section was connected to one of the big vessel, and then the discharge was connected to compressor. In low pressure event, the compressor's high section can create a vacuum or negative pressure inside the column, and if not stopped in time, it can lead to catastrophic failure. To prevent exactly, the system was designed smartly. We had a pressure transmitter monitoring the column pressure. If the transmitter ever dropped below the threshold value or safe limit, it would raise an alarm and automatically trip the compressor. But on that day, nothing happened. No alarm, no trip, no, just silence, and column collapsed. So when we started our incident investigation, we went through every bit of data, the logs, the trains, the history, trying to figure out what went wrong. So what we did, we have broken our problem into three simple steps, starting from sensor and then the equipment, the final element which has to take the action. So we saw that all MCCs were okay, and if there was a command from control system or PLC, it would have tripped the compressor. We saw the program was all good, and then we went to sensor to check that if sensor is behaving good or not, and uh, there it was. The pressure transmitter value was frozen. At first we thought the sensor had failed, but when we tested it, the sensor element was working perfectly fine. We simulated it with our equipment, lab equipment, all good. The real problem was inside the transmitter. The electronic card had frozen, holding the same output value even though the actual process pressure was changing or fluctuating. So system believed everything was normal while in reality the column was heading towards the collapse. That realization hit hard, right? We had found the what, but now came the how. How could we ensure this never happen again? How many more transmitters in our plant could behave the same way? And the major drawback or challenge we had, our PLC wasn't intelligent enough to detect a frozen value on its own. So if your transmitter has the same value for a long time, PLC was not able to detect that the value has frozen. I'm just talking about system design in the 1990s. Nowadays we have very intelligent system, but if you're working in plant, you may come across the system which was designed in 1960s as well. So just keep always curious. So what happened? So PLC was not designed or intelligent enough to detect the frozen value. So we did some study, and then being energetic engineer, I have came up with a good idea, and I proposed to develop a logic which can detect frozen value. So it will be kind of, you are having your EI value, and then you'll be putting a small block which will measure, which will keep monitoring the value of the transmitter, and if it sees that if there is a stagnant value for a long time, it will detect it. So we have developed this logic for one of the transmitter, and the configuration was like that. If it detected a frozen condition or stagnant value for a long time, it would alert the operator, and if still no action was taken within a defined duration, it would automatically initiate the trip. Or to action required to save, bring facility into safe mode. But then came another questions from the operator. How long is too long? Because you cannot configure any time over there. You can have like 5 second, 10 second, 30 second. Uh, so to make this truly reliable, uh, what we did, we went back and we did process safety time calculation. So uh, to try to understand like how much process will take to get to hazardous condition, and based on that we have defined time for each and every transmitters in our plant. For example, few transmitter we have configured 10 seconds. If the value doesn't move for 10 seconds, it will give an operator alarm. For some transmitter we consider 5 minutes as well. If value doesn't change, it will trigger an alarm. So this was one of the most important learning in my early career days, which has helped me to understand uh, the insights of the transmitter, the how system works, and then how as an engineer we can come up with the best fit for risk solution to overcome any of big challenges. So stay tuned, subscribe my channel. I'll keep sharing more and more. I bring 18 wonderful years of experience in oil and gas and new energy business. So initially I'm starting with all the simple topic, but going forward I'll also bring more topic about functional safety and more interesting stuff. So stay tuned and wait for next topic to be issued. See you. Bye.